first up, we're going to do literal equations. So we're going to go through in order, starting with quarter one. And we did literal equations like in the first unit really early on. Literal equations is when you have equations that have numbers, but mostly it's variables, and you're just rearranging the variables to have a different variable by itself. I'm going to give you the closest real-world example, and I have seen this on practice tests before. So this is the equation to turn Celsius into Fahrenheit. So F is Fahrenheit, C is Celsius. When you are solving these literal equations, you're always given what variable you want to rewrite it or solve it for. In this case, it is C. When we learned this, we highlighted the variable that we wanted to isolate and then moved everything away from it. So, for this one, we're trying to get stuff away from C. We're going to subtract 32 from both sides. The 32's cancel on the right-hand side, but on the left, this F minus 32, those are not like terms. We can't combine them. So we are just going to write it as F minus 32 equals, and we have 9/5 C left over. And we're still trying to get this C by itself, but it's not. So we have to deal with that fraction. Do you remember how to deal with that fraction? Multiply by the reciprocal. So we flip our fraction over and multiply. So that would be multiplying by 5/9 on both sides. So on the right, that makes those cancel out, so we do just have C equals over there. But on the left, that 5/9 has to be multiplied by everything on that side, meaning that we have to put everything on that side in parentheses. So we're just going to rewrite that as 5/9, parentheses, F minus 32, and that's it. That's your final answer. So, literal equations, typically when they show up on practice tests and the state test, they're going to give you something that has some real-world meaning, which is why I picked this one. You've seen this equation before in science. Even if you don't remember it or remember how to use it, you've definitely seen it before. Any questions? Lovely. Let's move on to the next topic. Compound inequalities. We are going to do two different examples for compound inequalities, just to make sure that we've got both of them. All right, so our first compound inequality has the word "and" in it, but then we have two completely separate inequalities that we have to solve. When I taught this to you the first time, whether the word is "and" or the word is "or," I taught you that you should cover up and only focus on one piece at a time. So for this one, we're just going to solve this first inequality all the way down until we get an answer. Then we're going to move on to the rest. What's your first instinct for this question to solve it? Multiply 7, distribute, right? You could also divide both sides by 7. And then you would just have to add 2 to both sides. Same answer, 2 different ways to do it. Because everybody said distribute, I'll do it that way. So we get 7x minus 14 is greater than or equal to negative 14. Add 14 to both sides. You get 7x is greater than or equal to 0. Divide by 7. X is greater than or equal to 0. Pretty straightforward. We bring down our word, and then we move on to the second part. You should be an absolute pro at solving these right now. So I'm just going to go through and do it really quick. So I distributed negative 3. I'm going to add 6 to both sides. And I'm going to combine like terms in the same step. I get 5x is less than or equal to 5. X less than or equal to 1. So this is my final answer. I've solved the whole thing, and this is what I get. And then from there, we may need to graph it on a number line, which you won't have to do the actual graphing part on the state test, but it is very possible that they give you the original question and ask which graph matches the solution. So if we can graph it on paper right now, then you can match it later. I've got to have 0 and I've got to have 1 on my number line, and just for ease, I'm not doing anything else. I am going to remind you how to graph these though. For the first statement, x is greater than or equal to 0, I have a closed point at 0 and my line goes to the right. For my second statement, I have a closed point at 1 and my line goes to the left. And my statement is and. So what do I care about? Where they overlap, in the middle. So my final answer is a closed point at 0, a closed point at 1, and the line connects them. That's the final answer. That purple line, barbell looking thing, would be the solution you would be looking for on your multiple choice. The other thing they could ask you is which statement represents the solution. And it could look like x is greater than or equal to 0 and x is less than or equal to 1. Or it could look like this. This is compact form and is also equivalent. You should remember that from the delta math, right? Because when you did the delta math, they didn't give you the word and. You had to write it in compact form. Good? Okay. There's one more version of solving compound inequalities that I want to go over with you. Because it's like the hardest version, and I just want to remind you of how to do it. So that problem would look something like this. We've got 3n plus 4 is less than 5n minus 12 is less than or equal to 4n. So for this type of question, when we're in compact form, we like to try to solve it in compact form. But when you have a variable in all of your columns, you can't do that. You have to break it down into 2 pieces. So you write your first piece, which is 3n plus 4 is less than 5n minus 12. And you have your second piece, 5n minus 12 is less than or equal to 4n. Because remember from the last problem, compact form is an and statement. So if we can go from and to compact, we can go from compact to and. Now we solve each of these just the same way we did the last ones. I like to move my smaller variable first, and 3 is the smaller coefficient. That doesn't necessarily mean that's the best way to do it, but I like my coefficients to be positive, especially when it comes to solving inequalities. If your coefficient's positive, then you don't have to worry about sign flipping. All right, I ended up with 8 is less than n, and for this next one, I am still going to move my smaller coefficient, which is 4n. That's going to give me n minus 12 is less than or equal to 0. Or n is less than or equal to 12. And then remember how we took compact form and broke it down? We can put it back together by smushing all that together. Which gives me this. And we love when a statement is in compact form because that is the easiest way to graph an and statement. So here's my number line. It goes from 8 to 12. 8 has an open circle, 12 has a closed circle, and then you connect them. And that is it. Is this coming back to you?
Yes.
Even if you don't like it, at least hopefully it's coming back to you. Okay. Next question. This. This was one of the most missed questions on the test. Does anybody want to guess which question number it is? It is number 10. It is the absolute value. The absolute value of 7x minus 30 equals negative 9. What do you remember about absolute value, Emma?
The absolute value of something can't be negative.
When you take the absolute value of something, it turns it positive. Come on. So, when you see absolute value by itself on one side of the equal sign and you see a negative on the other side, it is automatically no solutions. Automatically. Like period, the end. That's it. Now, let's do a solving question where it's not equal to a negative so that I can remind you how to do it. This is going to be the absolute value of 2x minus 3 is equal to 1. This is where the stuff on the inside of the absolute value could be positive or negative. So we have that 2x minus 3 could be equal to positive 1, or 2x minus 3 could be equal to negative 1. And then you solve each of them. This should be pretty simple. This part. Add 3, 2x equals 4, x equals 2, and then add 3, 2x equals 2, x equals 1. What do you remember from the delta math that you have to do next before you type in your answers? You have to plug them in. You have to check your answers. That sounded like what you guys were saying, right? You have to plug them in.
Yeah.
You have to you have to plug them into the original equation just to make sure that they work out. Because on this first question, on this number 10 from your benchmark, I'm going to tell you right now that almost everybody answered it properly and got the correct numerical answers, except if you had plugged it in, you would have gotten that the absolute value of -9 equals -9, which would give you 9 equals -9, which doesn't work. So, if you had remembered to plug it in, it wouldn't have worked out.
Got it correct on the second time because I tried plugging it in and nothing worked.
Yeah, so solve it correctly, remember to plug it back in. You plug it back in, nothing works. The only option is no solutions, okay? So you don't have to do this out on your paper. We can just quite literally do this mentally, right? So 2 times 2 is 4. 4 minus 3 is 1. The absolute value of 1 is 1. So that works. This one, 2 times 1 is 2. 2 minus 3 is -1. The absolute value of -1 is 1. So they both work. So our solution is x equals 1 and 2. On a test, it might look like x equals 1 or x equals 2. All right, I had one more request last period of what do we do if there's stuff outside of the absolute value bars? Like this. Right. We have to get rid of all the other stuff first before we can do positive and negative options. So we have to subtract 8 first, which gives me 3 times the absolute value of x plus 6 equals -3. And then we have to divide by the 3 on the outside. I end up with the absolute value of something equals -1. That is no solution because of that negative. Now, if you have an absolute value solving equation situation on the state test, you're going to see absolute value equals negative, and this is going to turn into like a 10-second question. You'll be able to pick the answer and move on because we went over this. Do you feel a little bit better now? Okay. Next thing we're just going to write really quick notes on that came next in our curriculum. It's parallel and perpendicular slopes. Slopes of parallel lines are what? Somebody said it. Yeah, the parallel lines look like that. They have the same slope. Parallel lines have the same slope. What about perpendicular lines?
Reciprocal.
Almost. You're half right.
Opposite reciprocal.
Yep, opposite reciprocal. Right, opposite means whatever the sign is, you make it the opposite of that. So if it's positive, make it negative. If it's negative, make it positive. Reciprocal, flip it upside down. Right, make it into a fraction and flip it. That was not on your benchmark, but writing it down may help you remember it for Monday and Tuesday. Okay, next, this is the good one. Domain and range. We're going to need a nice big reminder of domain and range. come on. There we go. Okay. All right, so domain represents all of your possible input values. So it represents X. It's going to look something like this, where the numbers are your boundaries, the restrictions on your domain. However, it is possible that if your domain is not restricted on one side, it's just going to be like X is less than a number. And then range is your Y values. Now, quick thing about domain and range, okay? Linear functions, straight lines, their domain and their range is all real numbers unless your word problem restricts it, which we'll talk about in a minute. Quadratic functions, absolute value functions, and exponential functions all have a domain of all real numbers. Domain of all real numbers, because you can input anything into that. However, all of those functions have a restricted range. An exponential function is your ballerina arms, and it sits on that imaginary shelf of your horizontal asymptote, or it clings onto it if it's below the asymptote. So, depending on the shape of your exponential function, your range is going to be all of the values of y above your horizontal asymptote or below. So it'll just be like y is greater than 0 or something. Your absolute value and your quadratic functions have either a maximum value or a minimum value, depending on if they open up or down. If they have a minimum value, meaning that they open up, that means your graph exists from the vertex and up, right? So your minimum value is the y value of the vertex, and it would be y is greater than or equal to that number. Okay, so if you can remember how to find the vertex, the y value of the vertex represents your range, either all above or all below. Okay, but let's practice really quick looking at a graph and telling what the domain and range are. We're going to draw a really small coordinate plane here. We're going to label it X and Y and draw our arrows at the ends. And then we're going to draw a function that starts at 2 and curves down and to the left. Yours doesn't have to be exactly perfect, but it does need to look somewhat like this, and please make sure you label that 2 on there. It's going to be super important. Bless you. And again, domain is left to right. It's how wide our graph is, okay? We do have a boundary where the graph stops and doesn't go further than this place right here. So we have a right-hand boundary, but it does go to the left forever because of that arrow. So we only have one boundary, and this graph is entirely to the left of that x value. So it is all of the values of x less than or equal to 2. You remember this? Great. All right. For the range, that's our y values, so that's how tall our graph is. Okay? We do have an upmost boundary right here, but there is no bottom boundary because of that arrow. So the graph exists entirely below the x-axis, which is y is less than or equal to 0. Okay, let's talk about restricting the domain and range. We're not going to write anything down. You are going to listen to me. Do you remember our super fun problem about Fred? But you remember it, right? Okay. The reason that I'm talking to you about it is because that is a problem where it's really easy to restrict the domain and range because it makes sense to you in your brain, right? Our domain represents the x values, which is time. It's how long Fred was existing in our word problem. So we start at time 0, right? Because that's where we start, at 0 seconds. And then Fred exists until the end of the word problem. And that's it. I think it was like 5 seconds. So your domain would be all of the values of x from 0 to 5, because that was as long as the problem existed. The y values represent height, right? So if we start at like 250 down to 0, right? So then the height, we're not talking about going below the ground in those 5 seconds. Therefore, the range would be restricted from 0 feet to 250 feet, okay? So like for that word problem, it makes sense to restrict the domain and range because that's all of the story. Even though if you graph that function, the line's gonna keep going down, the line is gonna go into negative x values, but we don't talk about going back in time, we only talk about the time when the story happened. Does that make sense? If they give you a domain and range question on the state test, I would say about 98% certain it would be a problem like that, where I think word problems are easier to restrict domain and range because it just makes sense. It's just all context, okay? Is that helpful? Any questions? No? Okay, this is the last topic from quarter 1. It's going to be 2 variable functions. Two variable functions are new to Algebra 1 this year. I'm not entirely sure if you're going to see them on the test or not, but a lot of students asked me just to review this really quick. So I'm going to show you 2 options. The first one is function notation. So it looks like f of a comma b equals 5a plus b. So it's just saying we have 2 inputs, and this is the rule that you use. So if I want to find f of 4 and 7, 4 is my A and 7 is my B. And that's it. You're just plugging stuff in and finding an answer. So this would be 5 times A plus B. Right? So 5 times 4 plus 7. 5 times 4 is 20. 20 plus 7 is 27. That's all. It's easy. I do not think it will trip you up. The only thing that I'm worried about, and I'm not even all that worried to be quite honest with you, is what it might look like if it gives you the symbol. And that symbol between A and B, or between X and Y, or M and N, or whatever the variables are, the symbol could be anything. The symbol doesn't matter. It's just saying like the rule for A with B would look like 3/4 A plus B. So the symbol is just taking place of the f of whatever. So if I want you to find 6 with 10. 6 is A, 10 is B. It would be 3/4 of 6 plus 10. Well, 6 plus 10 is 16. So this is 3/4 of 16. And then in my brain, I say 16 divided by 4 is 4 times 3 is 12. All right, one more thing to write down for this and then we're done. We're not even going to do another problem. I'm just going to show it to you. Sometimes you're going to see something that looks like this, where you have that symbol showing up twice. Guess what order of operations tells us? Parentheses first. Emma, literally what I had written down on my paper. Well done. You would evaluate 4 with 8 first, and then whatever that answer was, which I think it's 9, would go there, and then you'd do 11 with that number. So you would just apply the rule twice. You can do that. It is not difficult. You would evaluate 4 with 8 in this rule. 4 plus 8 is 12. 12 divided by 4 is 3 times 3 is 9. Okay? And then 9 would take over this place, and it would be 11 with 9. And then you would just do the rule a second time with 11 and 9, which would be 15. So your whole answer would be 15. Okay? I don't think you're going to see it. I don't think you're going to see it. I wouldn't worry about it. Also, I would like to remind you that not a single person in here has to get every single question right to beat your goal. So if this is a question that you choose to get wrong, totally fine. I'm not going to be mad at you about that. All right. I am moving on to page 3 now. And our next topic is sequences. We did sequences differently, or not differently, but separated. We did arithmetic sequences with linear functions, and then we did geometric sequences with exponential functions. I'm going to do it all together. You are given the explicit formula for an arithmetic sequence. It is a sub n equals a sub 1 plus d parentheses n minus 1. What is a sub 1? The first term. What is d?
Common difference.
Common difference. Remember, an arithmetic sequence is adding or subtracting, depending on whether your common difference is positive or negative. I've given you an arithmetic sequence, 12, 23, 34, 45, and so on. We are going to find a sub 40. That notation, a sub 40, means we are looking for the 40th term. We are going to use the explicit formula and plug values into it to find the 40th term. So, a sub 40 equals the first term, 12, plus, what's the common difference?
11.
It's 11. Parentheses, 40 minus 1. And it's 40 because that's the term we're looking for. Calculators. You put this in your calculator exactly like this. Tell me what you get. What is it? Yeah, 441. So a sub 40 equals 441. Good job. Any questions about arithmetic sequences? Okay, let's do geometric. Geometric is multiplying and dividing. A sub n equals a sub 1 times r to the power of n minus 1. A sub 1 is the first term still. And r is the common ratio, not rate as a decimal and not rate of change for this problem. It's the common ratio. Remember, if your sequence is dividing, we write r as a fraction or a decimal. And we put it in parentheses every time. All right, here is going to be our sequence that we're going to practice with. 4, 12, 36, 108, and so on. We are going to find a sub 12. So we plug this in, a sub 12 equals the first term, which is 4. We put our common ratio in parentheses every single time. What is the common ratio? 3 to the power of n minus 1. And for the love of God, do not put 12 minus 1 in your calculator. Put 11 in. Because if you put 12 minus 1 and you don't remember to do it the right way, you're going to get the wrong answer, and it will be an answer choice. On purpose, it will be an answer choice. So, to get the correct answer, who has it? 6 digits, right?
Yeah.
Go for it. 708,588. Great. I'm going to pause and make sure that you have this written down before I add one little thing to the side here. Do you remember converting geometric sequences to exponential functions the day I gave you the massive set of notes and you weren't allowed to ask any questions and you weren't allowed to say anything, and then at the end I wrote down, is there a shortcut? Of course there is. Okay. Do you remember how to do that? That's okay. Okay, that's okay. Here's the trick. F of x equals first term divided by the ratio times r to the x. First number divided by second number times second to the x was how I taught it to you. But because we are using formulas, it's just a sub 1 over r times r to the x. So for this function, it would be f of x equals a sub 1 over r times r to the x. That would be this sequence written as an exponential function. Here is what I told the last class. If this shows up on your state test, I think it's going to look one of two ways. They are either going to ask you which function represents the sequence, or which of the following represents the sequence, and you'll have multiple answers. Either way, if you are given the sequence, or you can create the sequence from the explicit function, like if you can go from explicit formula to creating a sequence, all you have to do is assign your input values of first term, second term, third term, fourth term. So 1, 2, 3, 4. Plug them into the functions and see which ones give you the right answers, right? Because if you plug in 1, it should give you 4. If you plug in 2, it should give you 12. If you plug in 3, it should give you 36. You know how to plug things into equations and get answers. So if you can't remember how to write this trick, you can still get this question right. You just have to plug in 1, 2, 3, 4 and make sure you're getting the answers of the sequence. You understand? Okay. So you don't need to know a sub 1 over r times r to the x. You also don't have to get this question right if you have an allowance of questions to get wrong. Finley.
You're saying just plug in the whatever number.
You plug in term numbers, right? You plug in 1, 2, 3, 4, and make sure they match the sequence that you've been given. Your outputs match the sequence. Your inputs are always 1, 2, 3, 4. Does that make sense? Does that answer your question? Okay. All right. You feel a little bit better about sequences? Okay. Let's do systems next. That was the order that we went in. So, I have two things about systems. We're going to do elimination. Here we go. 4x minus y equals 2. And 2x plus 2y equals 26. When we solve by elimination, we want to make we want to pick one variable to eliminate, make them opposite coefficients. I want to eliminate y. Tell me why I want to eliminate y. Why did I pick that one to be the easiest one, Bailey? Yeah, I don't have to multiply by a negative. I already have one positive, one negative. If I can avoid multiplying by negatives, I will, because that's where you're going to get tripped up the most. Like, you're going to make a silly negative mistake, and it's going to be an answer choice. You're going to get mad if you get it wrong. So we only have to multiply this by 2. I'm going to write it underneath just so that they're lined up already. So 4x times 2 is 8x minus 2y equals 4, and we add them together. Remember that they have to be lined up. X's, y's, equal signs, all of it. My y variables cancel out because that was the whole point. And I get 10x equals 30, or x equals 3. Great. That's exactly where we should be. What do I do now? Plug it in. You have 3 different equations that you can plug it into, and I truly don't care which one you pick. They're all going to give you the same answer, so long as you do your math right. I'm going to use 2x plus 2y equals 26 because there's no subtraction in there. And again, you're going to make a silly negative mistake, and it's going to be an answer. So 2 times 3 is 6 plus 2y equals 26, which means 2y equals 20, y equals 10. Final answer is an ordered pair. Great. Yes. Hold on. I can't hear you very well. Your most common mistakes are going to be answer choices on purpose. Okay. Next thing. Let's see. Types of solutions. I gave you this flow chart when we did systems of how to tell the types of solutions. You ask yourself if the slopes are the same. If the slopes are not the same, then you have one solution. If the slopes are the same between your 2 linear equations in your system, then you have to compare your y-intercepts. If the slopes are the same and the y-intercepts are the same, your system has infinitely many solutions. If your slopes are the same but your y-intercepts are not, you have no solutions. Hopefully you remember this little flow chart. Oh, I should. I didn't even think. I want to add vertex form next time, which is literally the next thing I'm about to go over with you. What a great segue. All right. Are we good with this? Can I move it? All right. I'm moving on to a new page. All right, next up, let's do some functions. All right. The absolute value function f of x equals a times the absolute value of x minus h plus k. A tells us if our function opens up or down. An absolute value is our v function. Do you remember what h and k tell us? So h is the horizontal shift and k is the vertical shift, but it is also the vertex. H comma k is the vertex of our absolute value function. It's the point, it's the maximum or minimum, it's where it changes. It shifts from like increasing to decreasing or whatever. Does this look an awful lot like something else we've worked with recently?
No.
Well, it should. This looks exactly like vertex form of a quadratic function, except parentheses and squared. Look at how identical they look. And guess what? In a quadratic function, A tells you if it opens up or down. H is the horizontal shift. K is the vertical shift. And h comma k is your vertex. Also, h is always the opposite of what you see inside. Yes? No. This is from quarter 3, but nothing else that we're doing right now is from quarter 3. I'm only putting this in here because look at how identical these are. I mean, like, they're almost exactly the same. In fact, while we're at it, I'm about to write down an exponential function for you too to show you where h and k show up. Here's the exponential function, f of x equals a times b to the x minus h plus k. Now, this one is a little bit different because we have a and b, and our exponential function doesn't open up or down because it only does one thing. It only increases or only decreases. So a and b work together to determine if it's above the asymptote or below the asymptote or whatever that may be. However, h is still your horizontal shift, k is still your vertical shift, and y equals k is your horizontal asymptote. That k value is the number of your horizontal asymptote. So there are your 3 different types of functions with the h and k and the plus and minus. All right, benchmark question. Piecewise functions. While we're in our function families, It was asked to do an evaluating piecewise function, so I'm using a test question because I believe that if you are given a piecewise function, you are going to be given the equation of a piecewise function and asked to evaluate. So this is the one you were given. This was number 41. It was the second to last question on the test. There were two pieces to your piecewise function. You were given a word problem to go with it, and then you were asked to evaluate h of 11. All you had to do was figure out which of the two equations to use and get an answer, and then you just had to read the rest of the sentence. So, Hayden, based on these two domains, which one does 11 fall into? The bottom one. So that's the equation we want to use. 62 times 11. Your answer choices were either 682 or 688. So start by narrowing down which one is the actual correct answer. What's 62 times 11? It is 682. And then for the question, it said X represented the number of hours worked. One of the answer choices said $682 for $11 an hour. The other one said $682 for 11 hours of work. And obviously it would then be 11 hours of work. But for this, you just have to figure out where does your input value belong in your domain, and then that's the equation that you use to plug into. Do you have any questions? Yes?
So I was looking for piecewise functions, and what I meant by the question is, you remember how in Delta Math, we were given like, was open circles and like closed circles on the graph. Like, I'm not comfortable with all of these.
You won't have to do that on the test. Yeah, I found out you won't have to worry about all the graphing and stuff on the test. If you have to read a piecewise function that looks like that, just know if it's an open circle, it doesn't equal that number, and if it's a closed circle, it does equal that number. You know how like on a number line when we did inequalities, it's open because it's not equal and closed because it is equal.
Like, with Delta Math, there was this thing that it was like something until 3 p.m. for example.
Those won't be on the test. Yeah, you should be fine. All right, great. I have one more thing for this page, and that is a small collection of exponent rules. I don't think exponent rules are necessarily going to show up on the test, but I think it would be helpful to go over them. I will say that exponent rules and solving radicals is one of the very first units in Algebra 2. They're really not that bad. But I'm going to give you just a collection of all the different exponent rules to practice. Alright, there we go. Alright. When you have two things, same base, and they're being multiplied together, what do you do with the exponents? You add them. So this is x to the 12 plus 3 is 15. When you are dividing, what do? Subtract them. 7 minus 2 is 5, so x to the 5th. Now, this one. What do you do with the exponents? Multiply them. What do you do with the coefficient? Yeah, you have to apply the exponent on the outside to the coefficient, which is 3 to the 3rd, which is 27. And then x, and that's x squared to the 3rd. You multiply those together, so that is 6. 27x to the 6th. What is anything to the 0 power? 1. So what is this equal to? 2. X to the 0 power is equal to 1, but 2 times 1 is equal to 2. All right, what about negative exponents? We have to make them into a fraction, but the coefficient itself does not have a negative exponent. So the coefficient stays on top, and the k drops to the bottom and becomes positive. All right, last one. It's truly like combining like terms. So x's go together, y's go together. If your x does not have an exponent, what's there? 1. Great. So this is x to the 4th and y to the negative 5th. But we have a negative exponent, so we have to rewrite it. But x doesn't have a negative exponent, so it stays and y drops. Okay. We're almost done. I have one more page. It is going to cover quarter 3, and then we're done. Mostly because we have already done statistics in the last couple of days, and we did some inequalities the last couple of days. So we just have to really cover like polynomials, factoring, foiling, the easy stuff. So let's do some polynomials. Let's just do some stuff with polynomials. Given the polynomial 3x squared plus 2x minus 1, how do you classify this? What do you name it? Degree and size. It is a second degree trinomial. Remember, the degree is the largest exponent. So our variable is x, the largest exponent is 2, so it's second degree, and it is trinomial because there are 3 terms. What about 4y squared minus 3 plus 2y minus 10y to the 3rd? It is third degree. Past trinomial, we really just call it a polynomial. But I think it would be a quadnomial, but we go monomial, binomial, trinomial, and then lots of nomials. Yeah. Somebody just asked if we would do some classifying polynomials. I don't think that they're going to want you to do this. I think that if you see this vocabulary, it will be in a word problem or in like just the question part of the problem. But it is helpful to remind you what these mean. All right, let's get into this stuff. Let's do x plus 7 times x minus 2. Do you remember how to multiply binomials?
Foil.
You can FOIL or you can do box method. I really, truly, 100% don't care which way you do it, as long as you get the right answer. What does FOIL stand for? First, outside, inside, last.
Oh, I don't know how to spell foil.
That's okay. Do you know how to do one of the methods? Did you get x squared plus 5x minus 14? Great, then I don't care how you do it. FOIL. All right. It is a second degree trinomial. Let's go backwards. X squared plus 4x minus 21. You can do X game if you can't see this. But some students are getting to the point of factoring where they can just kind of see the answer. I like to draw my parentheses and put my X's in, because I know that that has to be the case. Yeah, positive 7 and negative 3. If you were solving this quadratic, this would be equal to 0. You would set each of these equal to 0. Your answer would be the opposites. So it would be negative 7 and positive 3 would be your solutions if you were solving the quadratic. Right, slide and divide is for when your A is larger than 1. So A is 2 here. And we'll make it equal to 0 and we'll solve it all the way through. Okay, so slide. You take your A value and you slide it over to your C position and multiply it. So this becomes x squared plus 13x plus 30. And then equals 0. Now we have this, we can factor that. Yeah, this one should be a lot easier to see. 10 and 3. The step you're going to forget is we did the slide, so now we have to divide. We are dividing out our A value, which was 2, and 2 can be divided from 10. So 2 has to be taken away from 10, and it goes to live with the variable in the other parentheses. So this becomes x plus 5 and 2x plus 3 equals 0. Which means that we have solutions of our opposites, right? So negative 5 and negative 3 over 2. Or negative 1.5. Okay, we're so close to being done. Ooh, too far. All right. The discriminant. What is the discriminant? There it is, b squared minus 4ac. We were getting there, so close. The discriminant is what exists inside the square root of the quadratic formula. Now, who remembers what it means? The number of solutions. If you plug it in and it's positive, you have two solutions, meaning the graph crosses the x-axis twice. If you plug it in and it's 0, that means there's one solution, which quite truly means that the vertex is on the x-axis. If the discriminant is negative, it does not touch the x-axis, and there are no real solutions. In Algebra 2, you will learn that there exist things called imaginary numbers, and this quadratic has two imaginary solutions. It's just how they define the square root of a negative number, because it exists in math, but it doesn't exist in the real world, so it's not real, which makes it imaginary. I don't know. I didn't define it. It's not on the test. Don't worry about it. Negative means no real solutions. Okay. Who remembers how to find the x value of the vertex in a quadratic? I know Kaylee's got it because she's been putting it on her formula sheet for weeks. The x value of the vertex of a quadratic. Almost. Negative b over 2a, or opposite b over 2a. It is the x value of the vertex. It's also the axis of symmetry. We are going to use that for our very last piece today to rewrite a quadratic from standard form to vertex form. So given the quadratic y equals x squared plus 2x plus 3, we are going to rewrite that in vertex form, which starts with finding the x value of the vertex. So a is 1, b is 2, c is 3. Our x value is the opposite of b over 2 times a. b is positive 2, so the opposite of b is negative 2. Negative 2 divided by 2 is negative 1. So my vertex is negative 1, comma, I don't know yet. How do I find the y value of the vertex? Plug it in. So x is negative 1. We get negative 1 squared plus 2 times negative 1 plus 3. You can do it in your head, except 1 minus 2 is negative 1 plus 3 is 2. So the vertex is at negative 1, comma 2. What is the a value of this equation? 1. So I don't have to write a being 1. I can go straight to parentheses x opposite of h squared plus k. There it is. That's it.